afternoon, my dear friends. Today I am going to start permutations and combinations, continue part. Last class I explained fundamental principle of multiplication and fundamental principle of addition. What is the fundamental principle of multiplication? If an event A can occur in m different ways and following another event can occur in n different ways, then both the events can occur together m into n ways, which is called fundamental principle of multiplication. Next result, addition principle. If an event A can occur in m different ways, following another event can occur in n ways, then either event A or event B can occur in m plus n ways, which is called fundamental principle of addition. Based on, we have the questions. The first question, repetition is allowed. So that problem last class finished. So little change, that is variety thing. The problem is, take the second, that is third question. How many 4-digit even numbers? How many 4-digit even numbers that can be formed using digits 1, 2, 3, 4, 5, 6 and 7 if no digit is repeated? This is the problem. No digit is repeated. So to solve this problem, firstly we have to take the given digits using digits of 1, 2, 3, 4, 5, 6, 7 and no digit is repeated and also forming 4-digit even numbers. We have to form 4-digit even numbers without repetition. This is our aim, our goal this is. So here the best approaching idea, the first idea is create the positions. So like we have to take 4 positions. Now observing without repetition, which is called general condition. So doesn't worry. We don't worry about the general condition. Now we have to see the, do we have any primary condition? Yes. What is the primary condition? The primary condition is even numbers. So even numbers, how do you say that a 4-digit number is an even number? Unit place must be an even number. So I have to mandatorily start filling unit place even numbers only. What are the even numbers? So even numbers, how many are there? So even numbers are 2, 4, 6. These 3 numbers are allowed in the unit place. How many ways could I fill these 3 numbers in the unit place? So either 2 or 4 or 6. So number of ways is equal to 3 ways. So which numbers are allowed here? So allowed numbers are, remember, 2, 4, 6. These three numbers are allowed in the unit place. Okay, I take like the mark. It means one of the number has gone in the unit place. So take a pause. Having filled unit place. Now we have, since repetition is not allowed, the condition is repetition is not allowed. How many digits are left here? 6 digits are left. How many positions are left? 3 positions. So 6 digits. How many ways could I fill in the 1000th place? This is the unit place. This is a tens place, hundreds place, 1000th place. How many ways could I fill in this position? In 1000th place, 6 digits I could have filled in 6 ways. In the same way, how many are left? 5. This can be done in 5 ways. This can be done in 4 ways. Okay. What do? I filled this position, but I do not stop here. I filled next position, next position, next position, and then I filled it. So what do? Do I add or multiply? I have to do multiplication. So this is our required answer. Once you understand black diagram, we have to write long ways. So in long ways, very easy. How to write first? So number of ways to fill in the unit place. So you are writing number of ways to fill in the unit place. To fill in the unit place is equal to 3 ways. And this long way is very simple. Similarly, number of ways to fill in the 1000th place. 1000th place, how many ways? This is 1000th place. Thousand place is equal to 6 ways. Next, hundredth place. Number of ways to fill in the hundredth place. Is equal to 5 ways. Next one, number of ways to fill in the 100 over. This is next tens place. Is equal to 4 ways. Therefore, by using fundamental principle of multiplication, total number of ways is equal to multiplying 3 into 6 into 5 into 4 is equal to 5 into 4 or 6 into 5, 30. 30 into 12, that is equal to 360 ways. I hope that you understand this problem. Okay, it is clear. Shall we do one more question, same model? How many 4-digit even numbers, that is repeated condition, repeated model problem. Shall I give this one? Take the next question. Next question. Note down all of this problem. Number of ways to fill long ways, very simple long ways. Mainly we have to use black diagram. This is the analyzation part. If you analyze the question like this, if you understand, we can easily solve number of questions like this. Shall we go? Okay, let us see. Next problem. How many 4-digit even numbers that can be formed with fourth question? using the digits 1, 2, 3, 4, 5, 6 and 7 if digit is repeated. If digit is repeated, so take the given digits when digit is repeated. So digit is repeated meaning. So what is the meaning of repeated? Okay. So here this condition is not wrong. With repetition now we have to take. This is repetition model, very simple. So mandatory to fill here, I have to fill in the unit place. How many ways? 2, 4, 6 in 3 ways. So make it diagram like this. So since repetition is allowed, how many numbers do I have? I have how many numbers? 7 numbers. How many ways should I fill in this position? 7 ways. Since repetition is allowed, means here also 7 ways, this is also 7 ways. Repetition is allowed. Repetition is not allowed means one number only gone, remaining 6 there, 6, 5, 4 like this. Here repetition is allowed means, so we get 7. So 7 numbers are repeated. So now we are writing in long ways, this is only long ways. Number of ways to fill in this is the primary condition, 3 ways. The remaining position same. 1000 place 7 ways, hundreds place 7 ways, tens place also 7 ways. So we have to do it. What to do? I have to use fundamental principle of multiplication. So 3 into 7 into 7 into 7. This is equal to 3 into 49, 49 into 7, 343. Correct? Okay, now multiplying. 3 3 is 9, 3 4 is 12, 3 3 is 9. 1029 ways when repetition is allowed. When repetition is not allowed, 360 ways only. Total number of possibilities here 1029. Okay. Next model, little change that only. That is little variety only. That is almost all. It is exactly similar. That we have to see the problem. Take the question number 5. How many 4-digit numbers, 4-digit numbers greater than 3000 that greater than 3000 that can be formed, greater than 3000 that can be formed using the digits 1, 2, 3, 4, 5, 6 and 7 if no digit is repeated. No digit is repeated. This is the problem. So this is exactly similar. So here what is the primary condition? What is the general condition? In this problem the primary condition is the 4-digit numbers more than 3000. 4-digit numbers more than 3000. Okay, more than 3000. So that's why what to do here, given digits I have to take first. I take given digits. These are 1, 2, 3, 4, 5, 6, 7. We have to form 4-digit numbers, 4-digit numbers greater than 3000 without repetition. This is the question without repetition. Now what I do? We have to create the positions. This is the best idea. The good idea is create the positions. And here, what is the primary condition? Greater than 3000. What is the general condition? Repetition is not allowed. Since repetition is not allowed, okay? Here the condition is, what is the condition? Condition is on the leading position, correct? Because greater than 3000 means we should say here only leading position, first place. So what is the condition? The condition is on the leading position. That is only one condition here. So I have to start mandatory. Okay, na? I have to mandatory start by filling leading position. By filling leading position. What are those? So which numbers? So what numbers should come in? What digits should come in the leading position here? Quite of us, a few of believe that, few of them, they believe that here in the leading position, the numbers which are greater than 3000, 4, okay na? 4, 5, 6, 7. 4, 5, 6, 7, and they came with answer 4 ways. Actually, if you go to think in the leading position here after that, leading position, the digit 3, leading digit 3, okay na? Are they reliable greater than 3000? Are they reliable show that more than 3000 numbers, more than 3000 4-digit numbers? If I start with 3 here, is it reliable to show more than 3000 numbers? Yes, so because if it is 0, it is also 0, 2, 1 like this, it is more than 3000. Hence it is a more than 3000 4-digit number. So what you say that the number 3 is also allowed here. So the 4 ways is wrong. So which is correct after that? So with the 3, how many ways could I fill these 5 digits in the leading position? I have to fill in the how many ways? 5 ways. So beginners, they have to do the mistake. So don't think like that. We have to think exactly always. Which digits? That means what digits should come in the leading position important. So here 3 will come, 4 will come, 5 will come, 6 will come, 7 will come. So this can be done in 5 ways. Having satisfied this condition, take a pause. How many digits are left now? One of the number has come in this position. There are remaining 6 digits. How many ways could I fill in the second place? I have to fill in this one 6 ways. Following this can be filled in 5 ways. Following this can be done in 4 ways. What do I do? Do I do add multiplication or addition? So following, I do not stop in the leading position. I have to fill in the second place, third place, fourth place. That means further I filled. Further so multiplication. So we have used multiplication. This is our final answer. I hope that you understand these logics. Clear? That logic is mainly important. Many people they have made mistake here. They made mistakes. So don't do like that. Okay, now I am going to write a long list. So what are the here? Leading position, first place numbers. First place numbers are, which numbers are allowed? 3, 4, 5, 6, 7. These numbers are allowed. Okay, writing this is the process. Number of ways. Number of ways to fill in the leading position, that is first place. is equal to 5 ways. Next question. Next line, number of ways to fill in the second place is equal to how many ways? 6 ways. Next one, number of ways to fill in the third place is equal to 5 ways. Number of ways to fill in the fourth place is equal to 4 ways. So fundamental principle. Therefore, by fundamental principle of multiplication, total number of ways equals 5 into 6 into 5 into 4 is equal to 5 into 6, 30, 5 into 4, 20, 30 into 20, 600. Correct? 30 into 20, 3 to the 6, 600 ways. So how many 4-digit numbers more than 3000? 600 ways we have to fill here. Understood this concept? Mainly leading is easy. Here primary condition is important. Depends on primary condition. Here primary condition even numbers. Even numbers are given means we have to fill in the unit place. More than 3000. So we start with the leading position. Note on all of you this problem. Similarly, I have to take the question 4-digit numbers with repetition. How many 4-digit numbers greater than 3000 that can be formed using the digits 1, 2, 3, 4, 5, 6 and 7 if digit is repeated? Can you say like this a model? Very easily. What did I say? Okay, take the question number 6. Problem number 6. How many 4-digit numbers? Take the next question. How many 4-digit numbers greater than 3000 that can be formed using the digits 1, 2, 3, 4, 5, 6 and 7 if digit is repeated? Digit is repeated. Okay? Digit is repeated. So here we have to take the firstly, once again I explain, digit is repeated model. Take the given digits 1 to 7. We should form 4-digit numbers more than 3000 with repetition. With repetition this is. So which numbers, what numbers should come in the leading position? So leading position 3 allowed, 4 is allowed, 5 is allowed, 6 is allowed, 7 is allowed. How many ways could I fill in the leading position? 5 ways. So one number has come. Since repetition is allowed, how many numbers do I have? I have 7 numbers set because repetition is allowed. If I fill 3, the same number I have to reuse. Using number, reuse again. So that is repetition is allowed. How many ways could I fill in the second place? This can be filled in 7 ways. Following this can be filled in 7 ways. I could fill in 7 ways. I could have filled in 7 ways. So 7 ways. This is also 7 ways. 7 ways. So what do I do? Do I add or multiply? I have to do it multiplication. So writing is same. Number of ways to fill in the first place, 5 ways. Number of ways to fill in the second place, 7 ways. Number of ways to fill in the third place, 7 ways. Number of ways to fill in the fourth place, 7 ways. By fundamental principle of multiplication. 5 into 7 into 7 into 7. This is 5 into 343 is equal to multiply. Yes, correct. 5 3s are 15. 1 carry. 5 4s are 20. 21. 2. 5 3s are 15 plus 2 17. So 1750 ways. Follow this one. So like this, more than 3000 between two numbers, like we have to solve our questions, exercise problems. Now I am going to the one more problem. 7th question. What is the 7th problem? See here. Take the question. How many 4-digit even numbers? How many 4-digit even numbers which are greater than 3000 that can be formed using the digits 1 2 3 4 5 6 7 if no digit is repeated. If no digit is repeated. So here, how many primary conditions are given here? What are the primary conditions? What is the general condition? So first of all, I have to take digits. What are the digits? The digits are 1 to 7. And which digit number we have to form? We have to form 4-digit even numbers which are greater than 3000 without repetition. This is our question, our game. So generally what to do? We have to use position method, black diagram concept. Okay, there is here which condition should come first. What condition should come first means here greater than 3000 even numbers condition, like we have the confusion. To avoid this confusion, I have to give a best approaching method. We should follow only. No need any confusion. No need to think other things. There is an explanation is there. I will have you directly. These are the entrance point of model problems. Why? Because single condition is given, that is okay, theory level. More than one condition is given, that is the entrance point of view. Very very important. Do think always, whenever there is given two primary conditions in the problem, the best idea, break into cases at one of the condition. Break into cases at one of the condition. Anyone. So here which conditions are there? Even numbers more than 3000. Even numbers means what? What is the mandatory condition? We must fill in the unit place. So at unit place we have to take. What are the even numbers? 2, 4, 6. So we should break into 3 cases. So in the unit place, I have to fix 2 number, either 2 or 4 or 6. So like I have to fill in the unit place. So at 2, how many 4-digit numbers which are greater than 3000 find out. In In the same manner, how many 4-digit number means you need to place 4. Using 4 in the unit place, how many 4-digit numbers which are greater than 3000? Like similarly, we have to find out 3 cases. Then finally, either first case or second case or third case. It means what do? I have to do addition. Okay. In the leading position, which digits are allowed here? What digits should come in the unit place? In the unit place, already we have done. That is 3, 4, 5, 6, 7. These 5 digits are allowed in the unit place. How many ways would I fill in the unit place? These 5 digits. I have to fill in. This can be filled in 5 ways. Take a pause. Having satisfied this condition, how many digits, how many positions are left? There are 2 positions left. How many digits are in the rest? In the rest, already 1 digit fixed here, other digit has gone here. How many are there out of 7? 5 only there. So this can be filled in 5 ways. Similarly, this can be done in 4 ways. So what do? I have used multiplication rule. So 2 filled in only 1 way. There is no chance. Only 1 way. So the total number of ways is equal to here 5 into 5, 25. 25 into 4, 100 ways. Okay? Is it going to similar? No. Why? Because if I fill into 4, the number 4 is not allowed in the leading position. The reason is why? The reason is what? Repetition is not allowed. So general condition is existing here. So repetition is not allowed. Which digits are allowed? 3, 5, 6, 7. Only these numbers are allowed. So this can be done in how many ways? Only in 4 ways. Having satisfied this condition, so this filled in 5 ways. Okay? This can be filled in 4 ways. 5 ways, 4 ways. Now total number of ways is equal to how many? 4 into 5 into 4. 20. 20 into 4 is equal to 80 ways. So the third case, it is exactly similar. So this can be filled in how many ways? So which digits are allowed here? If I fill 6 in the unit place, 3, 4, 6. 6 allowed? Not allowed. 5 is allowed. 5, 7. This can be done in 4 ways. Take a pause. This can be filled in 5 ways. This can be filled in 4 ways. So using multiplication rule, this is equal to 80 ways. Total number of ways is equal to how many? 260 ways. So in long way, how to write? The number of ways to fill 2 in the unit place. Okay? To fill with 2 in the unit place equal to 100. The number of ways to fill 4 in the unit place is equal to 80. The number of ways to fill 6 in the unit place equal to 80. So therefore, by fundamental principle of addition here, either first case or second case or third case, total number of ways is equal to 100 plus 80 plus 80 is equal to 260 ways. So this is the problem. Whenever there is given two primary conditions, not general conditions. If there are 2 primary conditions, what do? We have to break into cases. At one of the condition, I break here at 2, at 4, at 6. Then we can add all digits, all numbers. That is the 4-digit given numbers which are greater than 3000. In the same manner, repetition is allowed. If repetition is allowed, no need to break into cases. Why? Because there is no different numbers, or that is we should use the same numbers. So like we have to do it the problems, very easy, repetition is allowed. You do it, try the questions. On tomorrow class we have to complete the remaining models. Okay, that is word formation or without zero completed. Now we have to find out with with zero model problem. Okay, some questions with zero, then after board questions like